of trigonometry. So today we'll be talking about trig angles, or trig ratios rather. Okay, so if we can look at this word, it is made of three parts. Gono, trigonometry, right? Trig means, okay, three rather means a three, like the angle 3, right? And then gono means angle, and then you also have metry, right? I hope you can actually see, guys, right? And then you have metry. Okay, let me do this a little bit. Wait for it. Metry, right? You have metry, which is measure, guys. Measure. All right, measure or measurement. Okay, so it is made of this. So today we'll be talking about trig ratios, right? Trig ratios, guys. But before we can actually go that far with this, guys, let's look at the Cartesian plane. Don't be afraid of these things, guys. Cartesian means, it's the name of a person actually. So he's the one who discovered coordinates, something like that, right? So you have to draw these arrows to show that your Cartesian plane goes to infinity, right? Okay, guys, so we'll be defining in this is the first question of your trigonometry. You know, trigonometry is made of many parts, right? There is geometry, guys. Geometry, it includes trigonometry, Euclidean geometry, 3 dimensions, and so forth, right? But now we are only focusing on trigonometry. Trigonometry, which part or section? We're talking about trig ratios, the first question of your trigonometry. You know, once you have your general solutions, you have your trig functions, you have your what else? Yeah, you have a lot of things there in trigonometry, but we are only focusing on the first question of trigonometry, which is trig ratios, right? Talking about the Cartesian plane back here, guys. We have your Cartesian plane. Of course, it has your x-axis horizontal line, that's your x-axis, right? And you have your vertical line, which is your y-axis, right? On your horizontal line, you know, we get your degrees, your angles in degrees, right, corresponding with your y values there. Okay, so then what I'm trying to say here is that Cartesian plane is really important to understand first, before we can actually go too far with this, right? So Cartesian plane, as you can see, these are two lines, two axes that are joined together, perpendicular to each other. You hear me? Perpendicular to each other. I'm sure you are familiar with the word perpendicular, which means 90 degrees. So you have this one here, here 90 degrees, it forms 90 degrees, forms 90 degrees, forms 90 degrees, right? So if you can look at this, you have your 90 degrees, you have your 90 degrees here, you have your 90 degrees here, you have your 90 degrees here, you have your 90 degrees here. So we'll be talking about the angle that rotates about this point here, right? Yeah. So then, guys, what I'm trying to actually say there is, here is like you have 90 degrees rotates, you have plus 90 degrees, that 180 degrees. That's why we say angles on a straight line, the sum of angles in a straight line are equal to 180 degrees. They are supplemental, meaning 180 degrees, perpendicular meaning 90 degrees. All right. So then moving on, we have another 90 degrees here, right? It forms now 270 degrees, right? And then we have another 90 degrees, that's 360 revolution. Now you hear me now? All right, guys. Okay, All right, without confusing you guys, you have what we name this in terms of quadrants. So this is your first quadrant, this is your second quadrant, this is your third quadrant, this is your third quadrant, and then we have your fourth quadrant. Right, so if you can actually say this, it is made of 4 quadrants. Right, these quadrants is where we actually draw our terminal arm. We have what we call a terminal arm or terminal ray. Right, terminal arm or terminal ray. This is a terminal ray, guys. Right, so we rotate this terminal ray about this point here, which is a point of intersection of these two axes. You have your y-axis, like I told you. You have your y-axis, you have your x-axis. All right. So guys, trig ratios are very interesting, right? These trig ratios are defined, we say is sine, right? You have your cos, you have your tan, right? So if you can check here, we said the first quadrant, it's 0 degrees. It will start from 0, guys, right? And then let me demonstrate it here, just to make sure you understand this, guys. All right. So if you can check, it starts from 0. Why it's 0 here is because this terminal arm, this terminal ray, is still in line with your x-axis, and then you pick it up a little bit, but here is still 90 degrees, and then you pick it up, you rotate it till it's stuck here, when it make 90 degrees, and then you go on rotate it, and then you let it go here, it forms 180 degrees. Like I told you, it's 0, 90 degrees, right? And then you have another 90 degrees, it forms 180 degrees. You add another 90 degrees, guess what? It's 70 degrees. And then you add another 90 degrees, goes back to 360 degrees. Right, guys, here is 90 degrees. Here, from here to here is 180 degrees. From here to this point is 270 degrees. From this point to this point, which means is 360 degrees. You complete your 360, 1, 2, 3, 4 quadrants. Right, okay. Speaking of your terminal arm, let's look at the terminal arm right now, guys. I hope you still with me. If you can check, your terminal arm will be on the first quadrant. But now let's check. If you can look here, since we have these 4 quadrants, we'll have an ambiguity here because we have 3 trig ratios. So we have to know what is what in which quadrant, right? So in the first quadrant, we have all these ratios positive. In the second quadrant, we have only sine positive. In the third quadrant, we have only tan positive. And the last, which is the fourth quadrant, we have only cos that is positive. So there are so many ways to actually cram this. All station to Cape Town, right? I'm sure you've been there in Cape Town. All right. So then, guys, let's talk about this. Remember, I said all station to Cape Town. All ratios are positive. Only sine ratio that is positive on the second quadrant, and then the third quadrant only tan that is positive, and then in the third quadrant it's only cos that is positive. All right, so we're moving on like that. Now I'm going to actually demonstrate this now by terminal arm. Like I told you, we'll be defining these ratios using theta in this quadrant, right? So if your terminal arm, now check this, guys. So we define these ratios let's first draw this terminal arm. We have to draw this terminal arm here. Can you tell? I took it from 0. I'm like taking this terminal arm like this, guys, right? Then I've stuck somewhere so it create an angle. Look, this angle is from here. This is the direction of this angle. You see, from your x-axis I'm rotating it, and then I got stuck somewhere here, and then it forms an angle, which is angle theta. Are you with me? All right, guys, I hope you're with me. So then from here, now you construct your perpendicular height. It must be perpendicular onto the x-axis like this. Always when you draw your terminal arm, constructing your right angle triangle, make sure your perpendicular height is perpendicular onto the x-axis. Can you see now, guys? All right. So if you can actually see this now, we'll be determining these ratios using your x, y, and r, right? Your r is your terminal ray. This part here, we name it r. And then since this part here, this perpendicular height is vertically, so we name it y. So this is your y unit. You know, this is y units, or rather y units. This side is y units, this side is r units, and then of course this one is horizontal. Your x-axis is represents your side, also is your x units. So check, guys, like I told you, you have so many ways to cram this. Now we'll have something, the word so this is h, which is your hypotenuse. This is o, which is your opposite side. This is a, which is your adjacent side, and then this is o, your opposite side, and your adjacent side, right? What do I mean now? Your adjacent side, super. You were coming nice. Now you introducing you adjacent. What are you talking about? Come on, guys. I'm sure you are familiar with a right angled triangle, right? Your right angled triangle was discovered by this Greek mathematician with his Pythagoras, right? Way back, mathematics to them used to be a culture. So he was just counting the squares of some particular shape, and then he found out that the square of the hypotenuse, is equal to the sum of the squares of the other two sides, which is y and x. The square of the hypotenuse, which is r, is equal to the sum of the squares of the other two sides. That's what it means, right? So we'll be using this to determine this. So we have your SOHCAHTOA here, which means S is your sine, C is your cos, and T is your tan, right? So which means if you can actually look at this, we'll have a sine theta is equal to opposite over hypotenuse, which is opposite over hypotenuse, OH, up over hypotenuse, right? Now we go back to our right angled triangle. So if you can look at this angle, which side that is opposite to this angle, side that is actually facing this angle is y. Can you see? Y is facing this angle, that is an opposite to this. That's what it means, which means it's opposite to this side, to this angle rather. So this one next to it, which side that is next to it, this one is hypotenuse. The longest side is always your hypotenuse. You don't have to worry about it. So the side that is next to it, beside it, this one, which is your hypotenuse, is your x. That will be your adjacent side. So it's up over hypotenuse, which means it's y over x, right? So we define these ratios in terms of up over r, your hypotenuse. So we define these ratios rather in terms of y, x, and r. That's what we're going to be doing, but we have to know the definition of your ratios. So if you look at cos now, cos theta, can you say a-ish? We said adjacent over your hypotenuse, which means your adjacent is your x, remember, next to it, over your hypotenuse is r. Have to know this, guys. You just have to know that when I'm talking about sine, when it comes to ratios, I'm talking about y over r. When I'm talking about cos, I'm talking about x over r. Moving on, you have your tan ratio. Tan theta is equal to, look at this now, is OA, which is OA, which means your y over x. OA, y over x. So it's going to be your opposite side over your adjacent side, which is your y over x. I hope, guys, you were here. If you were here, I would ask if you have any question, but unfortunately you're that other side of the world. All right, so then here what's going on is that you have your Pythagoras theorem. Your Pythagoras theorem will help you to determine the side that is not given, right? That's your Pythagoras theorem. And then your ratios will help you to determine these ratios and substitute to whatever equation that is given from a question that will be asking you to find the numerical value, right? So far